Okay, so today we're going to start the chapter that it covers surface area, it also covers volume and all those. So if you have a look ahead, the other thing is with surface area, so make sure your units are all the same. The other thing is, if you look here, this was a cylinder that they had like this. So they had a cylinder, and what they've done is they've cut it down the middle here. So they've done a little cut there, and you can see it opens it up. So this side down there is actually the length across there. So if you had the height of a cylinder, that will be that part of, that could be height or length. And where you cut it, actually along this top bit here, is that bit there. And can you see that that would, if you cut a tube in half, you get this rectangle piece, don't you? Yeah? And so that's why we can say the length of this is actually the circumference of the circle, because it would go, this length would just sit around the top of that circle to make the cylinder, yeah? So what you have to be careful with is sometimes they might say find the surface area of, an open glass. So if it was just a glass, say you had a glass there, you actually only have the bottom and then you have the bit around the side, yeah? So you wouldn't have one of them. So when you break it up, the surface area would be the area of that circle, which is pi r squared, plus the area of this. So say that was the height of the glass, you'd have, and this will still be 2 pi r, so it'd be 2 pi r times height, whatever. All right, so you just got to be careful and break it up and make sure you're doing the right thing. They might ask you, if they ask you, oh, we're going to paint this open glass cylinder inside and out. So that means you times that by 2 and that by 2, because you're painting the inside of it as well as the outside. Just be really careful, read the instructions and see how much the area. So surface area is where you get all flat pieces and you're going to as if you're going to paint each side and work out the area of the sides. And remember, a surface area will be measured in centimeters, squared units. So if it's centimeters squared. You will see that we've got in your notes, I'm not sure if I put them straight after that, or I might have put a lot of them at the back so that you could easily find the formula sheets. Now, you do get given a formula sheet in the exam, but what happens is they might not give you everything that you've got, and they might give it in a way that you're not used to using. So why we put these formula sheets in is so that you can get used to working it out and using one you want, and then you have that with you because we can take a bound reference book. Now we need to be careful with the conversions. So when you use a formula, you should have everything in the same units. So if you need to convert some length and area, so length is here. If you have to change an area from centimeters squared to meters squared, that would be there, you've got them. And same with volume and stuff like that. Now, probably the biggest one with volume is to make sure that you realize that 1 centimeter cubed equals 1 mil. So for example, if you had a can of Coke, say is 250 mils, well, that's actually 250 centimeters cubed. Yeah, it's 1 for 1. And then another thing just to remember, but it's all there, is 1,000 mils is equal to 1 litre. Yeah, so you might work out how many mils it is and then divide it by 1,000 if you need litres or whatever. All right, so and we actually have a hemisphere here. So you're looking for volume. So there's the volume of a hemisphere and the volume of a cylinder. So it was 2/3, wasn't it? Yeah. Just to see that you can believe me that the volume of a cone, there was the volume of the cone formula. So see how I know them off by heart, it makes me that much quicker. So in an exam, although you probably don't have time to keep flicking, so if you do, we're going to go here and I've got a few examples for us to do to show you. Now this first one's early on, so it really should be an easy. So if they said find the area of the shaded region, So really what you can say is you can find the area of the triangle, which is at this stage the only formula we've learned at the moment is half base times height. And then a minus, you could say the square. Wouldn't that give you the shaded area? So say if I had called that square was like green, if I cut that out, yeah, you'd be left with just the blue area. So the area of a square is length squared. So all you do is simply put in the data. So it's half times the base, which is 12, times the height, which is 10, and they're all in centimetres, so it's all good, minus 5 squared. So we end up with 60 minus 25, which equals 35. So we've got our answer there, 35. All right, and now this one is in 2016, and it's question 5. So they're supposed to be getting a little bit harder, but I don't know, seems pretty easy. So the water tank is the shape of a cylinder and a hemispherical top. So what you've got there is like half a ball and then a normal cylinder. When it says find the volume, so what you've got to do is you have to break it up. So you'll go, the volume would equal the volume of the cylinder plus the volume of the hemisphere. Yeah, I'll just call it hemisphere. So then you go and get the formulas for them. So if you go back and put them in, so it's pi r squared times height plus the cylinder. So 2 over 3 pi r cubed. Be careful with that one. That one's, the r is cubed. So then you pop in your data. So you got pi. What's the radius in this question? 2 meters, good. So we got pi times 2 squared times the height of the cylinder. What's the height of the cylinder?
5.
Yeah, good. It's just the 5. So times 5 plus 2 over 3 times pi times r cubed, which is 2/3. So you type that all into your calculator, exactly like what you just wrote there, and you get... Okay, so I end up with 79.6, so I'm going to say is 80 millimeters. So, sorry. So it's, what are we doing? Volume. So it'd be 80 centimeters, not meters, sorry, yep, meters cubed. Okay, so that's A. There's the volume. Okay, back. Go on to the next question. Now, once again, you've got... They said the grain storage of a silo is in the shape of a cylinder and a conical top. If you don't know what a conical top is, it's okay because they've shown you in a diagram. So what we might call this part is a cone. We call that a cone. And then we've got the cylinder. So when they say ask us for the volume of this, we're going to, once again, we'll write it out. Volume equals the volume of the cylinder plus the volume of the cone. Okay? And then go get your formulas. So volume from a cylinder is pi r squared times height. And the volume of a cone is 1/3 times pi r squared times height. Okay? So then go plug in. What's the radius in this question? So we're looking for the radius, and it is... Now, if across here is 10,
That's be 5.
yeah, so won't that be good? So you know radius is 5. So you can pop that in. So you got pi times 5 squared times, now what's the height of the cylinder? 16, good. Plus 1/3 times pi, what's the radius of that cone? It's still 5, good. Times 5 squared, and what's the height of the cone? Is 1.8. And you plug that in, and I believe it. Okay, so we get that to be 1304 when it's rounded. So beauty, there's my answer there. So in here, you write out your formulas. I already knew them. It makes me a lot quicker. And then what I can do when I go and check, all I'm going to do is check that I copied that right first, because that will help me pick up a mistake what will probably happen is you might have not cubed or something, you know, so it will help you. And it also saves a lot of time. That's question 4 or whatever, so yeah, it can save. All right, so then this one is question 8. This is the last question in last year's exam for trigonometry in the multi-choice. So you would expect it to be a little bit more detailed. It's not going to be quick, so have that in mind, and it might not be so straightforward. So let's go and have a look. All right, it says the slant edge x of this cone is shown, and they've told us the radius up here too. So we've got a radius of 2.5, and then they've said the slant edge x, and they've also told me the volume of a cone. Now, they said the surface area can be found using this formula of the cone. Now, they said the total surface area of this cone, so this surface area is including the base, and then they're asking you for that total surface area, can be found by. So if you have a look, let's go have a look. We need to find R. So what's the R? Because we need that for the formula. 2.5. Good. So 2.5 is R. But we also need to know what X is, don't we? So we can complete that. So if I come up here and I look at this, can you see that I have a right angle triangle there? Yeah? So I'm going to say, if I was trying to find a link with X and R, I'm going to say that's 2.5, that's X. Now, I'm going to call that the height of the cone. Yeah? So, I really need, if I was going to use that triangle, I need to get H, don't I? I would need H. Now, let's go look at what else they gave me. They gave me the volume of the cone. They said the volume of the cone equals 36. Now, I know centimetres cubed. Now, I know that formula for volume of a cone. Formula of volume of a cone is 1/3 times pi times r squared times h. Okay? Now, I'm going to say I know that equals 36, but I also know what r is. So couldn't I write this out as 1/3 times pi times 2.5 squared times h equals 36. How many unknowns do I have there? 1. Good. So I can pop in solve, comma, h, and you'll find out that h equals 6 when you do that. So now I know h, I can put it up here. Now what formula would I use with this? Pythagoras, good. Where I'd say x squared equals h squared plus 2.5 squared. So plug in what you know. We now know that that's 6 squared, and we already knew that one. So you can then do solve again, comma x, and we're going to work out what x equals. Actually, so sorry, h was 5.5. Gonna rub that out. And I think you find out that x is 6, sorry. Okay, so, and we end up with, so therefore you had to find the total surface area of the cone. So you go pi times 2.5 times 2.5 plus 6. Was it x 6? It ends up 67, so we can say roughly that one. Okay? So, can you see how you had to do 2 things before you could even do the question thing? That is why it's the last question. And I looked it up today, and only 51% of the state got that correct. And that's your hard one, apparently. Not hard. All right, off you go, 17F.